now, I think. Or no, something's wrong with the video. Okay, good afternoon, everyone. Sorry for a delay. We have some problem with the projector, but I think it's not really essential for today's lab. So if you could go to the wiki on the GitLab and scroll down first to the announcements. I have created a doodle poll for you just to vote for the exam dates and also for the assignment 2 presentation. Just select the option whichever is convenient for you. Just select as many as you can, and then we will decide based on that when to have the assignment 2 presentation and when to have the exam. So just refer to this doodle poll. You found it, right? It's on the wiki when you scroll down to the announcements. Yeah, as for the lab, if you scroll all the way down to the wiki again, there is lab 04 textures. There is a description of the lab. And as for the code, if you go to the repository where the previous labs were, you will find lab 04 code folder, where is the actual resources you need. And as a kind of cheating paper, if you get stuck, there is lab 04 _ solution folder where you can find the final solution. And for those who are watching the stream, I will just it's very bad that I can't show it here, but I will also very quickly show how the results should look, and then maybe I will show you one by one. So this is what is the expected outcome, just for a few seconds. Yeah, and let's start with the description. So for this task, yesterday we discussed textures, how to apply textures to our models, or how to put textures within our scene. And for this task, we will need a soil library, simple OpenGL image loader. That, as the word literally means, is a very simple one. It actually supports a few image types like bitmaps, and it loads its primary function, and I think the only one is to load the textures into the OpenGL. And like for vertex buffer objects and vertex array objects, textures are also objects that need to be called and bound. And here you see it's a matrix, 4x7 matrix, where you have like you remember when we discussed the strides, right, where we had the coordinates followed by colors or other parameters, and here we have like x and y coordinates, so the actual coordinates of the model. Then we have color information, and we have u and v coordinates, that is the corresponding position of this vertex into the texture space. And we need to load these coordinates and generate a buffer. And you see a piece of code here. With glgen buffers function, you select that you create one buffer object, and you indicate the identifier, that is text coordinate buffer in this case, and you need to declare it beforehand, and then you bind it as like we did for the vertex buffer objects. And in order to load the actual texture from the external file, you will work with the soil library, and you see the piece of the code with soil load image function. Yeah, sprite sheets, as we have mentioned many times throughout the course, sprites are small bitmaps that are inserted into the larger scene, and they're part of the scene. And the sprite sheet is just kind of atlas, or a collection of sprites where we refer to pick up the texture, desired texture for our task. And it's used oftentimes for animations, where sprite sheets contains separate sprites of an object in different rendering variations or in different conditions. As you see in this case, there is a movement of this guy that you see on the second page of the PDF, and on the sprite sheet, if you go to the lab 04 underscore code folder, and if you go to just a second. Yeah, you have to go to resources folder, then textures, and you will find the sprite sheet.png. It's a sprite sheet where we have the different positions of this model, in this case the guy running. So you have to pick up the sprites from this sprite sheet, and yeah, I will go to, yeah, the task is to first of all load the image, just one image from the sprite sheet, and it will be static, and then your task is to load other images and create the perception of animation. So you have to, you can control the frame rate, and you have to load those sprites from the sprite sheet one by one to have kind of some movement perceived on the screen. And yeah, there are 16 sprites, and you have to also figure out in this lab how you have to tackle the problem with vertices, vertex coordinates, so how to take the dimensions to pick up the right part of the sprite sheet. And yes, and as an extension or extra stuff, you can try to look into using a keyboard input to control the movement of this guy, and also would be nice to think not only on the result of your code, but also the coding style and professionalism. Here are some references that might be useful for you, and that's more or less it for this lab, I think. Yeah, and yeah, for animation you might also need to look at the transparency alpha value before calling drawing function. So here is also a piece of the code that might give you some hints. Yeah, any questions? I'm really sorry that we don't have the projector, because did you manage to follow what I was discussing now? The PDF and the sprite sheet? So if there are no questions, then you can start, and I will stop streaming.